Java 3D, how to manipulate local coordinate systems separately using the keyboard. This video explains how to move, rotate, and scale the parent local coordinate system TG0, and move, rotate, and scale the child local coordinate systems TG, TG2, TG3, and TG4 separately using the keyboard, which are already initially positioned in the source code explained in the previous video. What this program needs to do for the above purpose. 1. Moving each local coordinate system using the keyboard. The purpose of the previous video was to initially position each local coordinate system. Remember, transform group and transform 3D objects each have an internal 2D array called a matrix for calculating coordinate transformations? Moving the local coordinate system using the keyboard is one step more difficult. First, the matrix within the transform group object is copied into the matrix within the transform 3D object. After translating, rotating, and scaling the matrix within the transform 3D object, replace the matrix within the transform group object with a modified matrix. Then the transform group object is transformed, moved, rotated, and scaled accordingly. 2. Implementing the KeyListener interface, like inheriting its structure. For details of the KeyListener interface, check out the video. 3D models in Java 3D, beginners only 8 flying a primitive rocket. 709. To use the key-typed method, this main class needs to implement the KeyListener interface. A class that implements an interface must write all the methods defined by the interface, whether they are empty or not. You don't have to worry about the details of code. KeyListener interface. All the methods defined by the interface. 3. Using setCapability, transform group allow transform right. After initially positioning each local coordinate system, if we move it during execution, we need to use setCapability to tell Java 3D that we are going to move it at runtime. 4. Declaring variables outside any method so that they are accessible from outside the method, making variables global. For example, to access TG0 and T3D0, which is outside the createColorCube method, from the key-typed method, write the code like this. 5. Adding KeyListener. When a key event occurs, the event is sent to the listener. Source code explanation. Source code links in description. Feel free to use the source code to make your own Java 3D program. I reused the source code described in the previous video. Java 3D, how the scene graph works. 1. Add these. 2. Change. Implement KeyListener. 3. Add these. Make these variables global, so that they can be accessed from the key-typed method. 4. Add these. Used for coordinate transformations. 5. Add this. Via add KeyListener, register a KeyListener object that waits for a key-typed event to occur. 6. Change the variables from local to global. These parts are removed, so that they can be accessed from the key-typed method. 7. Add this. After initially positioning each local coordinate system, if you move it during execution without setting setCapability, you get an error something like this. This error is easy to identify and fix. The error occurred on line 249. Check the line. You will see that the error occurred when TG0 was rotated. Add this line of code so that TG0 can be moved, rotated, and scaled at runtime. Similarly, 8. Change the variables from local to global. 9. Add this line of code. 10. Change the variables from local to global. 11. Add this line of code. 12. Change the variables from local to global. 13. Add this line of code. 14. Change the variables from local to global. 15. Add this line of code. Taking each method defined in the interface, and writing what you want to do within the method or leaving it empty. 16. Add the key-typed method. TG0, TG, TG2, TG3, TG4. 16A. If the D key is pressed, move TG0 in the Z direction. As I explained earlier, the matrix within the transform group object is copied into the matrix within the transform 3D object. After translating the matrix within the transform 3D object, replace the matrix within the transform group object with the modified matrix. Then, the transform group object is transformed, moved, accordingly. 16B. If the D key is pressed, move TG in the Z direction. Since TG is initially oriented in this direction, if the D key is pressed, TG is moved in this direction. 16C. If the plus key is pressed, scale up TG0. The matrix within the transform group object is copied into the matrix within the transform 3D object. After scaling the matrix within the transform 3D object, replace the matrix within the transform group object with the modified matrix. Then, the transform group object is transformed, scaled, accordingly. If the minus key is pressed, scale down TG0. 16D. If the asterisk key is pressed, scale up TG. If the caret key is pressed, scale down TG. 16E. If the W key is pressed, rotate TG0 counterclockwise around the x-axis. The matrix within the transform group object is copied into the matrix within the transform 3D object. After rotating the matrix within the transform 3D object, replace the matrix within the transform group object with the modified matrix. Then, the transform group object is transformed, rotated, accordingly. If the R key is pressed, rotate TG0 clockwise around the x-axis. 16F. If the S key is pressed, rotate TG0 counterclockwise around the y-axis. If the F key is pressed, rotate TG0 clockwise around the y-axis. 16G. If the X key is pressed, rotate TG0 counterclockwise around the z-axis. If the V key is pressed, rotate TG0 clockwise around the z-axis. 16H. If the W key is pressed, rotate TG counterclockwise around the x-axis. If the R key is pressed, rotate TG clockwise around the x-axis. 16I. If the S key is pressed, rotate TG counterclockwise around the y-axis. If the F key is pressed, rotate TG clockwise around the y-axis. 16J. If the X key is pressed, rotate TG counterclockwise around the z-axis. If the V key is pressed, rotate TG clockwise around the z-axis. 16K. If the T key is pressed, rotate TG2 counterclockwise around the x-axis. If the Y key is pressed, rotate TG2 clockwise around the x-axis. 16L. If the G key is pressed, rotate TG2 counterclockwise around the y-axis. If the H key is pressed, rotate TG2 clockwise around the y-axis. 16M. If the B key is pressed, rotate TG2 counterclockwise around the z-axis. If the N key is pressed, rotate TG2 clockwise around the z-axis. 16N. If the U key is pressed, rotate TG3 counterclockwise around the x-axis. If the I key is pressed, rotate TG3 clockwise around the x-axis. 16O. If the J key is pressed, rotate TG3 counterclockwise around the y-axis. If the K key is pressed, rotate TG3 clockwise around the y-axis. 16P. If the M key is pressed, rotate TG3 counterclockwise around the z-axis. If the comma key is pressed, rotate TG 3 clockwise around the Z-axis. 16. Q. If the O key is pressed, rotate TG 4 counterclockwise around the X-axis. If the P key is pressed, rotate TG 4 clockwise around the X-axis. 16. R. If the L key is pressed, rotate TG 4 counterclockwise around the Y-axis. If the semicolon key is pressed, rotate TG 4 clockwise around the Y-axis. 16. S. If the period key is pressed, rotate TG 4 counterclockwise around the Z-axis. If the slash key is pressed, rotate TG 4 clockwise around the Z-axis. 17. Add these. We need to add these methods regardless of whether they are empty or not. Actually, we can't see local coordinate systems, but each color cube is connected to a local coordinate system, which is connected to the parent coordinate system. So we can imagine how the local coordinate systems move, rotate, and scale by looking at the color cube's movements. Running the program in Eclipse. Just type each key specified in the key-typed method to see what happens. The good thing about 3D programs is that you can see the results immediately. Thank you for watching my video. On my homepage, New Google Sites, I divided my how-to videos into groups so that you could find what you were looking for more easily. If you are interested in it, please visit the site. Links in description. Visit my channel to see more videos.